Our team name is Foreign IQ, and our problem statement is transformer-based end-to-end web application firewall pipeline. So our project is to develop a application firewall using a deep learning method called transformer. So why do we need that? So basically, that a firewalls are created with predefined rules. So with that predefined rules or the predefined signatures, if any unauthorized or unauthentication request comes to the firewall based on the predefined rules or predefined signature, it automatically rejects or ignores it. But uh, seeing our technology grows much faster, threaters get to know the uh, predefined rules or the predefined signature which the firewalls has. So if a threater already know what the predefined rule is, he easily makes a machine learning or some model to bypass the firewall and access through it. So our proposed solution is we developed a transformer based web application firewall that performs real time anomaly detection. So it does not do at one time, it does in real time. So it is a deep learning driven detection, replaces rule based signature or predefined rules. So the pipeline of a project is log ingestion, parsing, tokenization, transformer detection, and WAF decision. So in the log ingestion, all the logs, all the batch logs, the historical logs as well as the real logs are being collected, and then it is gone into the parsing segment where the data has been extracted by their key fields like parameters, methods, path, etc., and they're normalized. The unwanted data are removed, and that data is being tokenized for the model to recognize it much faster. So after tokenize, our model detects whether it's suspicious or malicious or not. Our transform model is trained only with normal requests because our model, if we train our model with only the normal request, it's well known how a normal request would be. So if any other request other than normal request comes into it, the machine model already knows how the normal request behaves. So if any malicious comes, it automatically rejects. And the innovation of a project is zero trust principle. The user even if the user comes into bypasses into the firewall with a normal request, their behavior is being monitored from end to end, like from login to log off, from end to end their behavior is monitored. And even if they bypass the firewall, if their activity is suspicious inside the system, our model will detect the request and it will block the access. So our innovation is zero trust principle, where every organization or every people who tries to bypass the firewall, the system will be verified, and it has end-to-end monitoring, behavior anomaly detection, which monitors the behavior of the user, and adaptive defense. The machine learning does not need any predefined rules. It adapt itself from the previous data or the real-time data which it gets. So we have made a prototype. We have fine tuned a deep learning model with BERT architecture in transformer model, and as you can see over here, we can like we have developed a prototype where we where we send the payload to test our model. And when we send the payload to test our model, as you can see in the right side there, which we have in green, like it validates the request. And what the model does is it saves all the normal requests to retrain the model, because once it's trained with normal request, the new normal request which evolves over time will be saved and it will be retrained automatically in the system. So that's another innovation. So we integrate the server with a sidecar, which means the user will to retrain retrain the model. Here we integrate this model with a server using the sidecar microservice, where the user will interact with the server like regularly, but on the other side of the server, which runs simultaneously, is that the our model, which gets all the requests that the user is interacting with the server, and the requests are being processed, and it's being classified into malicious and non-malicious things. And and the feasibility and viability of the project is the technical data and the data engine. These helps to build the system, and the viability, which has the operation feasibility, scalability, and practical impact, which helps to deploy in the real world. So here uh, the transformer based learning and the real time anomaly detection is highly feasible, and the retrained learning automated retraining scripts are highly feasible. And here it seamless integration. No matter how the user interacts with the server, the requests are being accessed or processed simultaneously. And this is our impacts and benefits. The practical impact of this project is it detects 0 day anomalies. Like, it doesn't need any predefined rules saying that this is an attack, this is a malicious request. It doesn't need anything like that. It analyze it by its own character, because we trained it with uh, a normal request. As you can see over here, yeah, you can see like we are training the data, the picture called model fine tuning. We are training the data with the normal request. So here the malicious requests, or the uh, alerted requests, are being uh, finalized or being shown in the real-time dashboard and real-time alerts, which is useful for further uh, investigation. And the business impact of the project is it reduces manual writing. The Like, it doesn't need any manual introversion of automated rescript. Any manual intervention is not needed to retrain the model. It automatically retrain its own machine learning ML model. And this is our resources and research and references. We took reference from these many papers, and yeah, that's no problem. And in the future enhancement, we plan to detect the behavior anomaly detection. So we have like that behavior anomaly detection needs a more computational space, and we are processing with that, and it needs more data. We are getting ready with that. And with this innovation, with this project, we will include that as well, which makes this project much more and bigger. So thank you.